everyone, it's Microwave Sam. In this video, I'll teach you Intro to Cryptography. How do you encrypt and decrypt something? If you're interested in cryptography or encryption and decryption in a beginner level, then this tutorial is for you. Now, taking a little step back, Intro to Security CTFs for Beginners was a video that I uploaded a couple weeks ago. I was teaching everyone about security challenges that are inside these CTFs because these small challenges are a great way to get started in building up your security knowledge. We created a website called ctf.slothparadise.com. Check the website out. It's a very useful website in terms of learning web security challenges for the first time. But web security is a little bit different from cryptography. Cryptography gets you a little bit involved, and this tutorial will kind of have a requirement of knowing a programming language. It will be much easier that way. So if you have an ounce of programming knowledge, this is a tutorial for you. Now, my buddy Alan Worth created this list of challenges, and it would be awesome, so awesome, if you give him a follow and tweet out to him saying thanks for this video. I checked out your cryptography tutorial and challenges. They were super helpful. You can give him some love. Now, we have compiled these encryption cryptography challenges on this GitHub open source link. You can visit the link in the description. Now, what are we going to do in this video? And that's the first thing that I should have talked about, is that let's say that you had this encrypted string, right? What does this mean? It doesn't mean anything to us because it's encrypted with a certain hash function. Someone maybe creates sort of password, right? Or encrypted message, right? Encrypts it with a sort of function for hashing or encoding the string. And then it becomes a blob, a mess that we don't understand. How do we decode this message? This is what this tutorial is about. And we're going to do two challenges that build up your skills for decoding and decrypting a problem like this. This is our problem, a security problem. We're a hacker and we want to decrypt this little string. How do we do that? Let's go back to the GitHub link. First thing that we're going to do is this GitHub link has two challenges that we are going to download immediately, ASCII. I've created this folder. I'm using Cygwin that has Git installed. Git is a place, or GitHub to be more correct, is a place where people collaborate on code. And most repositories are open source, which is great for the community to learn and get involved with collaborating on coding projects. What we do first is we use a command called git clone the link, and we hit enter because we need to download the code involved. After we download, we'll take a look at what is actually inside. Now, the first thing that we'll take a look at is welcome.txt. Here is what you see. Welcome. Here you will find some new challenges. Everything you need is in this folder. Key, welcome to the matrix. What does this mean? Well, this was based on a security CTF. Very simple challenges for security CTFs. Here we have our first key. Now, in the security CTF competition, these are security competitions where you find keys in order to get points. Every problem is a security problem, and we try to find our way to solve this security problem or break the problem in order to find these keys. And these keys will show up, and you get points for these keys. That's how security CTFs work. We are finding key, bracket, and the string inside the key. In this case, it's welcome to the matrix. And before you go even further, if you're fairly competent in programming in general and just problem solving, then I would highly recommend you to just pause the video right here and find the rest of the keys. There are two more keys, 3 keys in total. The first key is key welcome to matrix. Feel free to pause the video. I'm going through this tutorial live, so I may make mistakes, but try to solve the challenges on your own. I encourage it because the rest of the video will just be me solving the challenges. Now, we have something in scripts folder. And in the scripts folder, we have a numbers.py and a couple of other files. This numbers_helper.py, it just has some helper functions for the numbers.py file. We don't even need to look at these two files. All we care about is numbers.py, and we see something interesting. I'll open it up in my Sublime text editor as well. Now I will use Sublime to open the numbers.py. Now this is a simple Python script. You might not be familiar with Python, and for that, we aren't using anything too complicated in Python. We're using basic programming concepts. So if you don't know Python as a language, you can look in documentation and do some little Googling to figure out what this means. But it's fairly simple. I'll walk it through you. We have something that checks arguments. When you run the program, the usage is python./numbers.py with 2 arguments. You need 2 arguments to run this program. These 2 arguments are integers. We see it right here in the source code. And then we have this big number. Okay, what's this big number? Well, it doesn't refer to the big number, but then in this if conditional, we have 3 conditional statements that lead to you've got the wrong arguments, exit. Afterwards, if this if statement does not get triggered, then we see 2 print statements. Congrats, you had the right input, and then into string, big number times arg1. This will be the answer. We can tell because the line before it said, congrats, you had the right input. So I'm going to assume that the second print statement right here means that we have the right answer, and this into string will be the correct answer. So what we see right now is that this big number is multiplied by an arbitrary argument, some argument that will produce a string because it's into string. Into string is a simple Python function that was created in numbers helpers. If we take a look at numbers helpers, we can see that it has an int string. It converts a string to an integer with the same bit pattern, little endian. And we can see here that there's just conversion from the integer to the string. We can see that this is our decoding function. Now, in this challenge itself, this is not about how do we decode something, because we have the decoding function right here, and we have the encoding here. The challenge is about how do we solve a problem given the knowledge that we have in the source code. We see that there are 3 arguments, arg1 and arg2, or 2 arguments I mean, and these arguments follow 3 conditionals. That's what I was trying to say. Now, I will typically copy the conditionals because it's helpful to just write down what we know on a piece of paper or on a notepad. We do not want this if condition to trigger. So I will reverse what is in this if conditional. I want arg1 to be less than arg2. I want arg1 not to equal 1. So we can't do something simple like 1 time multiplied by this big number, because we want arg1 times arg2 to equal this large number. And here are the conditions for the problem to solve the problem correctly. You know, in the essence of cryptography and encoding and decoding something, the essence of decoding something, you go through the encoding process backwards. We have 3 conditionals that are kind of the way that this program is encoded. We just want to reverse things. And that's kind of the essence in general of any cryptography problem. You figure out how the problem is encrypted, and then you decode and decrypt the problem by doing everything in reverse. This will help you solve most problems, but not every crypto problem. And these are very simple challenges, so don't expect the ones in actual security CTFs or in actual, real life environments to be as simple as this. But you can solve a lot of problems this way by going backwards and seeing what you can do with the knowledge that you've been given in either source code or just in general. Alright. Now, once we have these 3 things, we have to create our own script, because everything is easier when you script the problem. Things are more automated, you can check a lot of varied answers, because we have this random 182, and we have to figure 2 factors that follow this condition. Okay, well, let us create a new file. I'm also going to solve my answer in Python, because Python is just a really simple scripting language. And what we want to do is basically we're just finding factors of this very large number. And that's basically it. And it can't be 1 in the number itself. So that's about it. I because we typically consider a problem to have in essence, it's not a trick problem. I can assume that this is a composite number, meaning that it can be divided by another number, creating two factors. Now, to do this problem, first I'll do check is equal to 2, or divisor equals 2. And we are going to make a while loop. Now, in the while loop, we have this big number, and we're going to use something called module. If you're not too familiar with programming, module can be used to check if another number is divisible by the other number. So what we're doing is, in essence, we are dividing by this number to check if it is not equal to 0. And if it is not equal to 0, then we add it by 1. It is not divisible by this divisor. So once it is divisible by the divisor, then we'll just exit out of the while loop, and then we have our answer right here. To demonstrate, I'll print the divisor out, and then I'll print what this number divided by the divisor equals. And I'll see what I get. That's all we need. Now let us open here and run our Python program. We get two numbers. Now this is interesting. So we know that when 139,033 appeared, it was divisible by the larger number. Because whenever you have a module that's is equal to 0, then you know that the divisor is divisible by the bigger number. That's how a module works. So we got a number that was divisible, so we print it out. And then after we print out the divisible number, then we just check what the big number divided by the divisible number is equal. And we get our two numbers. Why is this important? Well, these are the two arguments for numbers.py. We fulfill the requirements. In argument 1, that's less than argument 2. Argument 1 is not equal to 1. And multiply the two of them, you get the big number. Because we know that since this is divided by the divisor cleanly, the divisor multiplied by the divisor, well, the big number divided by the divisor, will equal to this big number again. Typical multiplication. Alright. Now, let's run the program with numbers.py with the first number, 139,033, because we need argument 1 to be less than argument 2, and the big number. And we see, congrats, he had the right input. Key, are you a math major? These are what the keys look like. So we got our second key, and we successfully figured out and decoded the math puzzle. We can see over here, like I said before, numbers.py, print, congrats, you had the right input, and it uses that numbers helper function to convert this larger integer to a string with the little endian bit pattern. We solved the problem, and we figured out how to decode that conditional. And we used the script to run through all the combinations, all the divisible numbers, until we reached the divisible number, and then we got the number that we were looking for. Next up is in the encryption folder. Now the encryption folder is a little bit tougher. See if you can try to solve this problem on your own. And if you get lost, then go back to the video and walk it through with me. We will first go traverse CD, change directory into encryption. And in the README, it says that this is a ciphertext that was generated by the script, encrypt.py. And to break it, you have to do a few things. Figure out the encryption, know the secret key, try decoding all the possible secret keys, and analyze those results to see which one most looks like English ASCII text. What ASCII means, if you're not familiar, is that ASCII stands for this American Standard Code. There are an extended ASCII table which goes up to 255. And they're basically a translation of numbers to characters. You can see it right here. Every number up to 255 has a certain character associated with it. It's a one-to-one connection. You can think of it that way. Alright, so we're trying to decode the ciphertext I showed in the beginning of this video. How do we do that? Well, the first thing you do is, if you're given the source code, you can always backtrack on everything. If you know the encryption function, then it is easy to decrypt anything. As long as you know the encryption function, you can decrypt it by reversing things. That's what I want you to take away from this tutorial. We can take a look at encrypt.py and we can see everything that it does to create that file. In this problem, it uses an additional B64 encode, B64 decode, utility functions provided by the library base64. We see that it requires three arguments. It runs Python encrypt.py. There is a character, X is a single character, and then there is a long string. So there's basically two arguments, but encrypt.py it's considered an argument. Now making it three arguments, but we only really care about these two arguments. There is a single character, and then there's the ciphertext, right? Or a certain text. And what it does is that it makes sure that the key should be one character, and it uses this symbol. Now this symbol, what it does here is that it goes through every character in the message. So let's say you had something called word, right? If you had something called word, then the for loop would just go through every character one by one and apply this encryption. This is a very simple encryption. But what it does is it uses ORD and CHR. What ORD does is that it changes a character to its number in the ASCII table. You can check out how this ASCII table works over here. I'll leave this in the description if you're interested in, but basically there's always a certain symbol involved, and you can exchange them in both directions. What if you want the number in the ASCII table, or if you want the actual character in the ASCII table. Those are control characters. Okay. Let's go back to the script. Now, that's what the for loop does. It changes these two characters into their number equivalents, then runs XOR on them, exclusive OR. One exclusive OR is that one of the two has to be true, but the other one, if it's true, then the other one has to be false for the whole thing to be false. Basically, we have something called XOR, and these are always used for true-false statements. So think of it as a true-false table. And the table typically looks something like this. So if it is true, then we have a false. If it's true, false, then we have a true. If it's true, false, we have a true. But it's false, false, we have a false. So this is how XOR works. It's exclusive OR, so only one of them can be true. But if one of them is true and the other one is true, then the whole thing is false. If one of them is true and the other one's false, then the thing is true. And if both of them are false, then it's false. This is how the table looks like. Now, no, that's not very important to know, but this is interesting. It uses encoding the output. So after doing this simple encryption, then it uses an encode to encode it into that ciphertext that we saw. What's important to keep note of and pay attention to is that this ciphertext was generated by this script. So whatever was done in this encryption script is this is the output, right? This thing is the output. That's very important to know because we know all the source code, so all we have to do is take this problem and think of it backwards. First thing that I'll do is I will copy the encrypt and then make a script called decrypt. After I've created that decrypt file, I'm going to open it up in my text editor, decrypt, like that. All right. these two files are currently exactly the same. What do we do first? Well, we see that we need to go backwards. So we see how they encrypted the output. Well, if they encrypted the output, of course we need to decrypt it. So what do? We say output is equal to, let me put it after this if conditional, because I want this if conditional to be triggered in case that the key is more than one character. Alright, output, instead of it equal to nothing, like an empty string, we want it to be equal to B64 decode the message. Because what we're going to do is we are going to put our encrypted ciphertext into the decrypt.py. And in this case, we need to decode it first before doing anything. Now we need to do the opposite of this XOR. What is the opposite of exclusive OR? Okay. In this case, sometimes you don't have this knowledge. In my case, I do, because I looked it up. But the property of exclusive OR is that exclusive OR is the opposite. And to figure this out, typically, I would do a lot of Googling when solving a cryptography challenge or security challenge in general. And you just look up information that you don't know. Google has a lot of information that you don't know. The inverse of exclusive OR is exclusive OR, because if you have something like this, C equals A exclusive OR B, then the answer is just A equals C exclusive OR B. What you do is just the C and A are exchanged, so it's just an inverse. And since we have the encrypted ciphertext, then all we do is we can leave this by default, because all it's doing is, first, we have the encrypted message, right? We're bringing it back in as the message. Message equals decrypted. Okay, it's not supposed to be output, it's supposed to be message, because if I do the output, then it would add equals the whole thing. So this is the right way, because I need to decrypt the message as the actual message, because we don't want it to be that encoded mess, right? So we're taking the message and we're going through every character of that message, and we're just applying exclusive OR again. It's not a very difficult decryption, but what I want you to take away with this is that if you have something that's hashed or decrypted, if you know the encryption scheme, then you will know that all you have to do is figure out a way to reverse the encryption to decrypt something. And in this case, the inverse of an exclusive OR is exclusive OR. So this is very simple, but let's say you had something else like an OR an AND with a like 0xFF or some hexadecimal word, or something even randomized with a seed, then things would get much more complicated. But this is how, this whole cryptography thing works. Then finally, I can just print the output, because I need to take this backwards, right? Alright, so once we have this, we have to create a function that takes advantage of this. So we will create something called decrypt_answer.py, a new file. And what we want to do here is that we want to run our decryption. Alright, so what do we do? How do we make this happen? Okay, so first we need to run the other script. Now, how do you do this in Python? Well, typically I would Google something where I would see how to run another Python script from Python, right? Because this is what we want to do. And we see a Stack Overflow, a bunch of Stack Overflow links help us. We see that we can do something called exec file, but that's in Python 2. Here's a good one. Python 3, this works in the same way. There's a library called subprocess, and we can call this script with subprocess. Okay, that works. Now that I know how to do that, I can start using it. Import subprocess. And since we know how ASCII works, there's a number of characters from 1 or 0 to 255 that translate from number to a character. So what we want to do is start at 0. But I know that the equivalent of 0 in the ASCII table, I think it's 0 again. I don't know. Let me check the ASCII table again. Alright, yes. It should be this null, the null character. And null characters wouldn't be the secret key, so I'm going to skip 0. Alright, so I start at 1, and then decryption is equal to, or let's call it ciphertext, because that sounds cooler. Okay, ciphertext. We'll copy and paste this thing. I think that I need these spaces in the beginning. I'm not completely sure, but it was a little odd for those spaces, so I'm going to leave them in anyways, and I don't think they would do anything with the message itself. Alright, so while the number is less than 256, because we want to script this process, we could check every single number and translate it to its ASCII character one by one with the decrypt.py, but we want to take advantage with the essence of programming, that we can automate things while programming. That's why I'm doing this. Now, what we want to do is first, the character will be char the number. CHR translate a number to its ASCII character equivalent. And then afterwards, we want to use that subprocess.call, which was available in that Stack Overflow link. And we want to run decrypt.py, leave a space, then the first argument is the character, another space, and the second argument is the ciphertext. Then we just do shell equals true, and that's it. That's all we need to do. And then we add 1 to it, because we're just going to go through all 256 of them, or 255 in this case, since that's not a very big number and we can just script through the whole thing. And I think that's basically it. That's all we have to do. Simple script to automate this process for us. Let's open our terminal and we'll run python decrypt _answer. Output is not defined. Oh, I know why. Because I erased it before. So I will put decrypt equals, no, it's output. I'm thinking about something else. Output equals quote quote. I deleted this before because I made a mistake of putting B64 code as an output, but it's just output equals empty string. Then I'll run the problem, but that's a lot of stuff. The answer is here, but I would have missed this if it wasn't here. A useful tip is that if you ever want to save the output of a program that you're running, you can use this symbol. The less is a greater than symbol. Then we'll put it into answer.text. We'll wait until this finishes, and we'll see our answer in answer.text. That's basically it for that problem. All we did was we looked at our source code, we looked at how the encryption worked to create the ciphertext, and we just did things in reverse. And if we open up answer.text, maybe putting it in Sublime would be easier. Oh, weird. Okay. We open it up. We see a bunch of stuff. Sometimes they errored out, but what you can do is use this slash. This is in Vim, by the way. Slash is used to find things in Vim, and we can search for key. We know that all of the problems on security CTFs typically start with key or flag, so we can search for those words, and we find our answer here. Key secret codes with XORs aren't very secret. Perfectly true. Those are the two challenges that we had created to learn about cryptography, encryption, and decryption. Hopefully you learned a thing or two. Leave in the comments what keys that you have found by yourself, perhaps. And make sure you follow Alan, because Alan worked hard to create these beginning challenges. Thinking of, like, let's say you were an absolute beginner. You just did your intro to computer science course and you want to learn about security. These challenges are great because they're very intro friendly. But let me tell you, security CTFs, if you're interested in them, you can go to ctftime.org. Security CTFs, the real ones, are much harder than the challenges that we have given you. But you need to start somewhere, and this is a great way to start learning. Thanks for watching. See ya.